Hi everyone, this is Team Salty. I am Alan.
I'm Jiayu.
I am Hong Yi. To rule in a game League of Legends, it is important that you understand the most effective way to accumulate gold. This in-game currency is used to buy items in a shop that provide champions with bonus stats and abilities, which in turn is one of the main ways for champions to increase their power over the course of the game. Before we start, we delete 5 predictors, game ID, which obviously is useless, and the 4 predictors shown in the slides that have NA values. We then fit GoDiff against everything else. In our Model 0, we checked for multicollinearity with the VIF function, and here is a heat map of the 6 predictors that are involved with multicollinearity. We can then group them into two, one consisting of champ level diff and EXP diff, and the other containing the rest 4. We keep champ level diff and kills in our future models and delete the rest, and thus we arrive at our Model 1.
In our Model 1, we further delete some insignificant variables. We check our p-value of each variable, and we realize the p-value for killed Baron Nashor is 0.93, much higher than our threshold p-value 0.05. So we delete this variable and get Model 2. In our Model 2, we further reduce the number of variables based on model selection. We decided to utilize the Bayes information criterion and got the result of the optimal number of variables is 38. So we only kept those 38 variables in our final and third model, we call Model 3.
In our final model, we got an R-square about 0.95, which counts for 95% of variance in GoDiff. Then we make a model diagnostics. In the residual versus fitted plot, we observe constant variance. In the normal QU plot, the arrows follow a normal distribution, and in the leverage plot, we first calculate a leverage point as shown. There are some high leverage points, but they are not so influential. After that, we select some of the marginal model plot. They clearly indicate the relationship between y and the predictor is similar to the relationship between y hat and the predictor. In order to get a fitted transformation, we also use the inverse response plot. We find the optimal value of lambda is close to 1, which indicates the current model is close to the best fit of our dataset.
And here in our final model, we have the most important features variables of our model. If we check the most important variable, which is champ level diff, it accounts for about 10% of our model. And to win the game, of course, you have to upgrade your champ level, and things like destroy the first tower is also very important. However, things such as kills is not probably that important as many people have expected. We also consider some further approaches of our model. For instance, we can transform some X. Here we show some examples of transforming 6 axes, but that would require knowledge beyond this class as we cannot transfer them back in a linear model. So basically that concludes our model and conclusion and presentation. Any questions?